Welcome back. We already created our first example, which reads a socket data stream and processes it in real time. In this video, I'll talk about Spark's built-in streaming sources and create one example to read streaming data from a file source. So let's start. Apache Spark offers you 4 built-in streaming data sources: socket source, rate source, file source, and the Kafka source. We already used socket sources. This source allows you to read text data from a socket connection. The socket source is not designed for production usage. So, you should not be using it except for learning or some other testing scenarios. The rate source is designed for testing and benchmarking your Spark cluster. It is a dummy data source which generates a configurable number of key value pairs per second. I am not going to cover this data source in this course. However, if you want to use it, you can refer to the documentation. Using the rate source is straightforward compared to other data sources. The file data source and the Kafka sources are the most commonly used streaming data sources in real-life Spark streaming projects. I'll leave the Kafka source for the later section and cover the file data source in this video. So, let's define a problem statement. You are working for the XYZ home furniture and kitchen utensils retailer. They have hundreds of retail stores across the country, and they also have an online presence. XYZ management decided to transform itself into a data-driven organization. As a first step towards that goal, they created a data collection pipeline to collect all their invoices to a central data center. The data ingestion pipeline collects the invoices from the sales channel and dumps them into a distributed storage at regular intervals. Let's assume you have a directory in HDFS or S3. The ingestion pipeline collects data for a while and saves a bunch of records into a JSON file. So the input directory keeps getting new JSON files one after others. A single invoice record looks like this. So you have some simple fields such as invoice number, store ID, and delivery type. We also have a complex column such as delivery address. We have an array of complex records for the invoice line items. You are then asked to create a Spark application that reads the input data files, flattens the invoice records, and writes it back to a different directory. The flattened record looks like this. However, each invoice should generate one or more flattened records. For example, this given input should generate 4 output records because we have 4 line items in the input invoice. Make sense? How will you go about this requirement? One approach is to write a simple Spark application that reads all the files in the input directory, flattens the invoice records, and writes it back to the output directory. However, you must schedule this application to run at regular intervals. Let's say your management want to do it every 5 minutes. So, you can simply schedule your simple Spark application to run every 5 minutes. However, you cannot read all the data files every time. Suppose you process 3 files for the first execution. When you start your application again after 5 minutes, you should only read new files that you haven't processed in the previous execution. You may find different ways to handle this problem. A straightforward approach is to archive the files after processing it. You read 3 files in the first time, transformed it, and then moved those files to some other directory. This way, you will not see those files in the next execution. This approach looks simple, but it is not so easy to achieve. You have to write a lot of custom code. You will also have to handle the failure cases. What if your job completes writing some records, but fails in between before you archive your files? You do not want to miss any records, and you also do not want to create duplicates. This requirement is popularly known as exactly once processing. The point is straight. Handling failure scenarios and achieving exactly once processing is a complex requirement, and it needs a significant amount of time to code and test. We do not want to invest that much time and effort when Spark structured streaming is there to offer all of this. All we need to do is to create a stream processing application using the data stream reader file source. Let's do it. Here is the initial project template. I already have a Spark session and now I'm ready to read a data source. Let's code it. I'm creating a raw data frame. So we start with the Spark session. Call the read stream to get a data stream reader. Then we set the format. I want to read JSON data files, so format is JSON. The next thing is to set some options. The only mandatory option is to set the path. I'll be reading data from the input folder. Input is the directory name in the current directory. If you are reading from HDFS or S3, you should provide a fully qualified path for the input directory. Finally, I'll load the data. The load method will return a streaming data frame. Reading a file stream is almost similar to reading a file. You will use the spark.read method to read a file and get a standard data frame. However, you will use the spark.readStream to read a streaming file and get a streaming data frame. Make sense? If your data is coming as CSV, you can set the format as CSV. You can even use the CSV options such as header and date format, etc. The point is straight. The read stream allows you to read any supported file format in the same way you read them to a standard data frame. Great. What is next? We want to process this data frame. But what is the schema of this data frame? You might be expecting Spark to infer the JSON schema, right? However, by default, schema inference is disabled for the streaming sources. But you can enable it. Let me do it. I'm setting spark.sql.streaming.schema inference to true. This option will enable schema inference. Let's print the schema and see what do we get. Good. Looks like schema inference worked. What is the next step? The rest is simple. We have an invoice such as this, and we want to produce this. Taking out these simple fields is straightforward. Select expression, right? Let me write it. We start with the raw data frame and use select expr. What do I need? Invoice number, created time, store ID, POS ID, customer type, payment method, delivery type, delivery address.city, delivery address.state, and delivery address.pin code. The rest of the fields are coming from the invoice line items array. We cannot take it until we explode it. So let me explode the invoice line items. So this data frame is exploded data frame. What is the schema now? Let me check. Good. We are almost there. Now, all I need to do is to rename these columns. So we start with the exploded data frame and use the with column to add simple columns. Finally, we drop the complex column. That's all. We are done. And now we have a flattened data frame. Make sense? What do you want to do next? Simple. Create a writer query and write the flattened data frame. Correct? What format do you want to write? Let's do JSON. Where do you want to write it? Let's push it to the output directory. You should also set the checkpoint location, right? One more mandatory setting is the output mode. Let's use the append mode. I'll talk about it in the next video. You can also set a name for your query. This name will show up in the Spark UI. Finally, start the query and wait for it to terminate. We learned about the triggers, right? Do you want to set a trigger duration? Let me set a 1 minute trigger. Great, we are good to run it and see it in action. However, I am stopping here and take this further in the next video. I'll also talk a little more about the internals of file-based streaming sources. We'll learn some additional options and also talk about the sync and the output mode. And finally, we will execute this example and see it in action. See you again. Keep learning and keep growing.